So if A of I is equivalent to A of J, what I will do, I should say that so some unique elements, some elements are same, so the array is not unique. So just I can say return false. I can say that time itself I can say return false. Otherwise, when all the two for loops complete and this if condition never become true, then I'll come here and say return true. Right? So this is what the algorithm entirely is. So I'll take an for loop that runs from 0 to n minus 2 and another inner for loop that runs from I plus 1 to n minus 1, checking only one thing, that is whether an element is equivalent to another element in a given array or not. If it is equal, I'll immediately return false. Else I will return true. Right? So far so good, the algorithm is.
Yes, sir.
So first note, yes, right. So now I'm having the algorithm. I want to go for the time complexity analysis. Now, how many for loops are there?
2.
Two. So how many summations will be there?
2 summation.
Two summations will be there. So let me write the time complexity. I want you guys itself to explain me how to do this. You should help me on how to derive the time complexity. It will be something slightly different. So it can go for some big and bit, but it will be easy, right? Time complexity analysis. Now help me. How to do start? So I can say something like summation.
Summation
What will be the limit?
I equal to
I equal to
0 to
0 to n minus 2. Okay, first summation is completed. That is outer for loop or outer summation. What will be the inner summation value? Summation.
1 to
I will put j here. Whatever variable in the for loop it is there, same variable use here. J is equal to what I should put here.
1 to n minus 1.
Don't say 1. Here it is what? I plus 1. So put the same thing here also. J is equal to I plus 1. If there is I plus 1 only, na? So you should put I plus 1 to what is on the top?
N minus 1.
N minus 1. What will come inside? So for running this equalization condition, I should require 1 unit of time. So I will put 1 here. So what will be the answer here? How I can proceed here first? So inside a constant is there. You are having a summation with upper limit and lower limit. How can I write here? I should use the formula u minus L plus 1. So keep the outer summation as it is. Don't change anything in the outer summation. Outer summation is just like I is equal to 0 to n minus 2 only. I am not changing anything in the outer summation. In the inner summation, what is u value?
Answer.
What is u value? U is n minus 1. What is L value? What is L value?
I plus 1.
I plus 1. So u minus L, what will come here? N minus 1. That is u minus, this is u value. N minus 1 is u minus L. What is L? As you said, it is I plus 1. U minus L plus 1. I'll put 1 plus 1 here. Into the constant value. So what is the constant value here? My constant value here is 1. So I'll put here into 1. Solve this, what will come? Summation I is equivalent to 0 to n minus 2. And here I can right click this as n minus 1 minus, put the minus inside, what will come? Minus I minus 1 plus 1. So into 1 will be changing now. So what will come now? What will come now? Very good.
Minus I plus 1.
Plus 1 or minus 1?
Minus plus 1, sir.
Plus 1 now.
-1.
Minus 1 it is. Because minus 1 and plus 1 will now cancel. This one and this one will get cancelled and I'll get n minus 1 minus I. So it is n minus 1 minus I. Now it is very clear now. I have already explained you the basic formula, right? Now if anyone says me how to proceed, then you are great. Can anyone say how to proceed? Shall I use u minus
Sir,
L formula here?
Upper minus lower plus 1 into n minus I minus.
You
No,
are saying
sir.
are you saying u minus L formula?
No, sir. Yes.
How to proceed then? Why I should not use u minus L plus 1 formula here? Why I should not use?
Sir, for only one constant, we use u minus 1.
Great. Our only constant is there. I can use u minus L plus 1. Here I am having something like I, which is a limit variable. I is present inside. So I should not use the u minus L plus 1 formula here. So what I will do is, I will make this separate. So I'll do one thing. You just say me whether I'm doing it correct or not. Whether it is mathematically, I can write like this or not. I'll write like for I is equal to 0 to n minus 2 n minus 1 minus summation I is equivalent to 0 to n minus 2 I. Can I write like this or not?
Yes, sir. Correct.
Yes. So what I am doing, I'm just separating the summation in between the terms. I'm separating this term. If I combine also the same term will come. So both summations are common. If I take it common, summation I is equal to 0 to n minus 2, n minus 1 minus I can get like that also. So same thing I'm actually separating. Now, shall I apply u minus L for this n minus 1 term? This is n minus 1. What is the limit variable here? I is not present here. Can I use u minus L plus 1 here? Yes or no?
Yes, sir.
Yes. So I'll get here u value is n minus 2. What is L value? Minus L value is 0 plus what is plus 1 into n minus 1 constant. You don't think that n is on the upper limit, how it has become constant? N is, we are not using, the only limit variable is in the lower limits. Okay, so in minus 1 minus, you can quickly say this, we just completed this. For I is equal to 0 to n minus 2 I.
N minus 1 into n minus 1 by 2.
Yes, very good. If it is I is equal to 1 to n or 0 to n, both are same. Why? Because if I add 0, nothing is going to change. So if it is I is equal to 0 to n, we will say it as n into n plus 1 divided by 2. If it is I is equal to 0 to n minus 1, I will say it as n minus 1 into n by 2. If it is I is equal to 0 to n minus 2, I will say it as n minus 2 into n minus 1 divided by 2. That's what we discussed in the basic formulas, right? So it will come like what? N minus 2 into n minus 1 divided by 2. Am I good?
Yes, sir.
Yes. Thank you. Now I'll proceed. So here I'm having n minus 2 minus 0 plus 1. So what I can come here? Minus 2 plus 1. What will be the result? N minus 1. So n minus 1 is there here. Another n minus 1 is there here. So n minus, this complete term is 1 n minus 1 into, this is 1 n minus 1. So can I write it as n minus 1 the whole square? Can I? Yes, minus, here another n minus 2 into n minus 1 by 2. N minus 2 into, or I can also multiply inside. If I multiply, what will happen? N squared minus 2n minus n. I'll get minus
3n.
3n. If I'm going wrong, please help me. Okay. Minus 2 into minus 1 will be 2 divided by 2. I'm not putting the minus inside, just I'm having like this. Right? Getting into this, n minus 1 the whole square. What is n minus 1 the whole square? N squared minus 2n plus 1. So if I want to take LCM, this 2 will go here, right? I want to take LCM in this 2 should be multiplied with 2 into n minus 1 the whole square. So what I will make, I just put 2 here in the whole bracket. Then I will put minus inside. So minus n squared plus 3n minus 2. So from this itself, I found that what will be the answer, because while finding the worst case, I can omit all the constants, everything. But just for making you very clear, I'm just solving it fully. Okay. Okay. So far, so good.
Yes, sir.
Yes, sir. So please take screenshot so that I'll get some space. Please take screenshot. I'll go to some new space. Can I?
Yes, sir.
Yes, thank you. Separate. Okay. Now what I'll get? So this can be written as is equivalent to 2n squared minus 4n. Help me. What will be the answer here? 2n squared
Minus 4n plus 2.
minus 4n plus 2 minus n squared plus 3n minus 2 minus n squared plus 3n minus 2. So the whole divided by 2. So what will be the final answer?
N square minus n by 2.
Great. N squared minus n divided by 2. Exactly right. Okay. So according to the principles of finding the asymptotic notation, what is the constant here? 2 is a constant. Remove the 2. And you are going to find the worst case and not the best case. If I was taking the worst case, I should take the maximum polynomial here. What is the highest polynomial here?
N square.
N squared. So what will be the final answer?
N square.
Big O of n squared.
Big O of n square.
What is the best case here? Big omega of n.
Big
Big O of
Big
n.
omega of n. If I take the lowest polynomial, then it is big omega of n. Now, can you give any example on how I can get a result in n time itself? That is, in a single for loop, I should get the result. If the array is sorted and none of the elements are actually being changed, or if they write that, then I can find it in n time itself. For example, I'm saying you something like 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Okay. How many comparisons will be taking place here? 1 will be compared with 2, 1 will be compared with 3, 1 will be compared with 4, 1 will be compared with 1. So how many comparisons happened? Only 4 comparisons for 5 element array. So when the result will be false, but my algorithm is completed. So it is best case. If I was able to find the result that the array is not unique in the first iteration of the outer for loop itself, then it is the best case. Then it is the best case. So the best case will be big O of n, right? So far so good. The finding unique elements in the array complexity.
Yes, sir.
Sir,
Yes, sir.
sir, then what
Yes.
about
So
average?
when you come for
Sir,
like, come again, come again.
what about average case, sir?
No, usually we will not have a pen and paper analysis for average case. So when we actually go for average case is if we are not able to fix either the upper or lower limit, I'll be going for an average case. For these kind of small problems and all, we should be in a position to strictly say what is the worst case and the best case. When you will be going for average case is if you are not able to figure, you can say some average results. Averagely, this algorithm will do like this. Like that, you should be in a position to say. For what problems? Some big tough problems there you cannot put the boundary exactly. If you are not able to put the boundary exactly either in the upper or lower part, then you can go for an average case.
Sir,
Yes.
sir, if we use sort function before these for loops, then what is time complexity, sir?
The complexity of the sorting algorithm is big O of n squared in the worst case. Right? I'm having several sorting algorithms like merge sort, quick sort, bubble sort, insertion sort, selection sort, radix sort. Many sorting algorithms are there. Each sorting algorithms will have an worst case and the best case and best input case. Three cases are there for sorting algorithms or any algorithms. With respect to the input, the sorting algorithm complexity will be different. But generally, when I say the complexity of a sorting algorithm, it is big O of n squared. So for sorting, you will take one n squared time plus for doing this thing, you'll be taking one extra time. What is that is if you sort everything, again you have to compare, right? If you sort also, you should compare, right? So you will be having some extra time, that is big of n squared plus once you sorted, you will be getting some elements better, so you can get something closer to big of n. So it will be big of n squared plus big of n. Now
So,
I like, yes.
sir, so overall is n square, no, sir?
No, that was I'm coming to say. If it is big O of n squared plus n, what will be the result? Big O of n squared. If it is big O of n squared plus big O of n, what will be the result? They are not same. They are not same. They are two different polynomials. If there is a single polynomial, then I should take the highest degree in that polynomial. If there are two different polynomials, then I should not compare them. Am I making it clear?
Yes, sir, clear, sir.
Yes. So in this we have to proceed. This is actually a very nice question. For this, what I will do an extra thing is I will make you a table like what we did for asymptotic notation. I will give you a table with at least some 5 different sorting algorithms. For each sorting algorithms, I will explain how they will be behaving with respect to the inputs, what is their worst case and what is the best case. Why I'm doing this is one thing is to as we said, it is actually important for this many algorithms, and another thing is searching, sorting are the most basic algorithms that will be rapidly used in any kind of algorithms. Like we in science will be doing, right? If when we find any medicine, we'll be testing it with rat or cat, like that animals, right? Likewise, when you go for any complex algorithm solving, the immediate logic what comes to our mind is searching or sorting. So whenever you go for any algorithms, whether your algorithm uses searching or sorting, or like that they will be asking, because those are major basic algorithms rapidly used in many algorithms, right? So we'll be discussing that also in a table wise manner, clearly explaining which is better, which sorting algorithm is better. For example, we say an sorting algorithm as quicksort. Whether quicksort is the quickest sorting algorithm? No. Then why it got a name quicksort? Everything will be analyzing. Do you know that we already completed data structures, right? So you'll be in a position to answer this. Whether quicksort is the quickest sorting algorithm?
Yes, sir.
So no other sorting algorithm defeats quicksort. That's what you are saying?
Sir.
Is it so? Yes or no? I think Ramagan says yes. What is Deepak answer? I couldn't hear you, Deepak.
Yes, sir.
No, then if quicksort is best, then why I'm going for something called as heap data structure, max heap, min heap, those kind of heap data structure, why I'm going. And then if quicksort is the best sorting algorithm, then why we are still studying bubble sort, insertion sort, selection sort, merge sort and all? You haven't think like this, you are actually thinking like quicksort is actually the quickest algorithm, am I right?
Yes, sir.
Yes, but that's not actual case. I'm just asking you, if quicksort is going to be the quickest of all the sorting algorithms, then why still those earlier sorting algorithms are still existing? Still many are using bubble sort, many are using merge sort. Why? Everyone should use only quicksort, right? Why they are not using quicksort alone? Still many algorithms are still existing for sorting.
Space complexity.
Great space complexity, and because of that, one person will succeed. That person is called as merge sort. Very good, Deepak. You are actually impressing more. So, because of that, we say that merge sort is best. Any other reason?
It's recursive.
No, sir.
I think constants are
Recursive, how recursive in a sorting algorithm? Even if I do recursive, I cannot do a sorting algorithm without two for loops. Surely, no two for loops is needed for any sorting algorithm. That is a standard procedure. Two iterative variables we require. Below that, none of them is actually having that. Right. So, but there comes a person called as heap. You know heap, right? Heap tree, heap data structure, min heap, max heap. Do you know that?
Yes, sir.
Yes. What is the power of that person? What is heap data structure? What kind of algorithms some people like, if in data structures, if we see some people like a sorting algorithm, 5 people came and said, see, I am doing selection sort, I'm doing insertion, I'm doing merge, quick, radix. Many people came and say, so what is your time complexity? When everyone asked them, they say from big O of n squared to n log n we can do like that. Up to n log n is our best case, like that they said. And for some input we will perform even more better, like that they are actually saying, these 5 people. Suddenly one person is coming and saying and asking these 5 people, what is your worst case complexity? These 5 people are actually saying that I can, in our worst case is big O of n squared. And this heap is actually saying I can do it in big O of 1 time. Everyone got surprised. How an heap sort algorithm can do in big O of 1 time to the maximum worst case of big O of n time. How sorting can be done in single for loop. That is actually a very big wonder. That's why heap is actually still persisting. Another thing, what heap is using? Heap is using nothing but a thing called as priority queue, right? Everything you should have studied in data structure, right? Priority queue. Yes, do you know priority queue also? Yes. So heap uses priority queue and does that. Though I hope that you have studied everything in data structure. Anyway, we will have a small recap on those sorting algorithms, right? Now, finding unique element in a given array, time complexity analysis is clear, right?
Yes, sir.
Yes. Shall we proceed? Shall I erase this? If you give permission.
Yes, sir.
Yes. Take screenshot. Yes.
Yes,
Now
sir.
the third one, we'll see the algorithm and it will be most easiest one. We have used it from first year. We are using this matrix multiplication, right? This is one of the most famous algorithm. We are using it from our first semester, second semester, third, fourth, everything we are using this, right? Now, so you can actually say me now how to start this. Okay, say me how to start. Matrix multiply. Can I give the name like matrix multiply, matrix multiply like that? And how many inputs I need? M1, M2, M3. Three inputs I need. Okay. So now we can state what are the inputs parameters. Inputs M1 0 to n minus 1. Next M2 0 to n minus 1. These are the inputs, right? Next, what is the output? M3 0 to n minus 1. I can do one change here. I don't want to represent M3 here. Why? Because M3 is going to be my output matrix. I want to multiply matrix 1 and matrix 2 and produce the result in matrix 3. Right? Now, can anyone quickly say how many for loops are required in matrix multiplication? 3 for loops. If it is matrix addition, 2. If it is matrix multiplication, I say 3. So now for I is equal to 0 to n minus 1. Next, for j is equal to, let's join with me, n minus 1. What I will do, I can just make M3 of ij equivalent to 0. Just I am assigning and making it a 0 matrix. Next I am coming with K matrix for K is equivalent to 0 to n minus 1. M3 of Ij is equivalent to M2 of Ik, sorry, plus C is equivalent to M3 of Ij plus into M1 of Ik into M2 of Kj. Am I correct? Tell me whether I am correct or wrong.
Yes, sir. Correct.
Yes.
Yes, sir.
Yes. So this is actually M3 of Ij is equal to M3 of Ij plus M1 of Ik into M2 of Kj. Finally, I will come and return M3. This is what the matrix multiplication formula is. Right? That's it, right? Have I missed anything? Is it right?
Yes,
Is it right? Yes. So how many for loops totally?
3.
And how many summations then? I is equivalent to what will come here? You say me quickly, fully you say so that I'll write fully.
Equal to 0 to n minus 1.
Okay, next.
J equal to 0 to n minus 1.
Next.
K equal to 0 to n minus 1.
Very good. What will come inside? 1 unit of time constant. Why? Because that addition will take 1 unit of time, we assume. So it says K is equivalent to 0 to n minus 1. 1. So what will be the answer? We'll be solving one by one. This is my U and this is my L and this is a constant. So what I can do is I can directly take those the U minus L plus 1 formula and I can apply here. So I'll first take the first both for loops exactly same. So these for loops are same. K alone I'll be doing separate. So for K, what is my U value? N minus 1 minus 0, that is a lower limit, plus 1 into the constant 1. So what will come here? Minus 1 and plus 1 will become will be cancelled, and what I'll get?
N.
N. I'll get here N. Next, how I'll proceed? Now I can take, this is also a constant. I can take the second summation and I can execute now, right? Instead of writing, I'm just copying and then pasting. So what will come here? This is an upper limit and this is a lower limit. So what I will get? N minus 1 minus 0.
Minus 0, 0
Exactly, very good. Plus
into N.
1.
1
N square.
Very good, very good, very good. Into N. So what I will get?
N square.
I'll get N squared. And I am having one summation also, that summation I'll put. Now solve for the I summation.
Cube.
Yes, answer is N cube, that's it. So I'll get again N minus 1 minus 0 plus 1 into N squared. So minus 1 and plus 1 will get cancelled. And what is the result? How should I write this result? There is no constant and only one polynomial degree is there. So I can directly write that degree as big O of N cube. Am I making it good?
Yes, sir.
Yes, so far so good. Yes.
Yes, sir.
Yes.
Yes, sir.
So in this class, we have actually discussed on how to solve a non-recursive algorithm, and we can thoroughly understood three formulas. That is, one is u minus l plus 1 into constant. For a constant summation formula, then sigma I is equal to 1 to n formula, that is arithmetic progression, n into n plus 1 divided by 2. And using that formula, I actually took derivations like sigma I is equal to 1 to n minus 1 means n minus 1 into n by 2. If it is n minus 2, in the sense n minus 2 into n minus 1 divided by 2, and so on. So these three formulas I took as a base, and I solved three different time complexity analysis. Those are finding max element in a given array. Next, checking whether the array is unique or not, and third is matrix multiplication. And the thing to understand here is your design and analysis of algorithm is actually the core component of your entire BTech CSE, and one of the most important subjects for GATE. If you want to get a GATE exam, this algorithm is actually the most important of all the subjects. So you can actually, when you are getting an opportunity to write MCQ exams also, so you keep in mind, given any problem statement to you or any given algorithm to you, you should be in a position to analyze the time complexity and say, yes, the time complexity of the program is this. If you are in a position to say that, then you are the best computer engineer. If you are able to say this, you are the very good software engineer, right? The person who is coding, right, he is not a best person. A person who is writing an efficient algorithm is actually best person, because an efficient algorithm sometimes coding is just using the syntax and then typing, that anyone can do. But writing a best algorithm, a person with very good IQ, the very good logical skills, mathematical skills alone can do this. Okay, so you just understand the complexity of everything. Now, speaking with MCQ perspective also, you just keep in mind, if it is a maximum element in a given array, big O of n. If it is unique, it is big O of n squared. If it is matrix multiplication, it is big O of n cube, and like that, right? This is actually the summary of this class, right?